Well, hello guys and welcome back to Mr. G Physics, the channel that is going to help you to improve your marks in physical science. Here we're going to be answering question 1.1 from this self-assessment challenge test. This question is really tough, so we're going to look together. The question says a motor is used to raise a box of mass m through a displacement of 2 meters at constant velocity of 2 meters per second over a 2 second period. Which one of the following represents the power of the motor? And this question seems easy, but it's not that simple. Okay, let's write the data on this side here. What we have first, the displacement is going to be equal to 2 meters. We have that the velocity is equal to 2 meters per second. All right, 2 meters per second, and this velocity is constant. That is also important here. And now here is the tricky part. It says that the period is equal to 2 seconds. That is not the time to move that thing off, but the period. So what we have to look here. So this one is not the time. Look at the velocity, and this velocity is telling us that this motor is moving 2 meters in 1 second. So every second, according to this velocity, this is going to move 1 meter. In 1 second, 2 meters, pardon. So if the displacement is 2 meters, it means it took actually 1 second to move this object from this specific displacement. So the actual time here is equal to 1 second. All right? And now we are looking for power. Power is equal to the power of the motor. So that is equal to the work done by the force of the motor, let's say by the force, divided by the time, not by the period, but the time. Okay? So now here, how we are going to calculate this force? We can use the work energy theorem. Net work is equal to change in kinetic energy. Now we have a problem here, which is not a problem. The velocity is constant, therefore the change in kinetic energy is 0. So we have that net work, let me fix that one, net work is equal to 0 there. Okay, so now what forces are acting here? It's to lift. We are lifting or raising a box. So we have actually the work done by gravitational force, and we have the work done by force. In other words, the work done by this force plus the work done by gravitational force is equal to 0. We can substitute the formula for those two forces, that the work done by those two forces. That we have that the work done by force is equal to, which not, let's substitute it on this side, I'll tell you now why, plus mg displacement multiplied by a cosine of 180 degrees, because the object is being raised up and the gravitational force is pointing down. That is why this angle is, and let me fix, because you know my handwriting sometimes is confusing. 180 degrees, all that is equal to 0. This one is minus 1, remember that one. So this one is the work done by the force minus mg displacement is equal to 0. Therefore from here we can write it down in this space here. The work done by the force is equal to mg delta x. Now we can substitute the numerical values here. So let's see, work done by the applied force is equal to, the mass is m, we don't have it. The acceleration due to gravity is g. Let's substitute, because you see in the options they use g, but the displacement is 2. All right, so let's substitute this one now here in the formula for power. All right, and when we substitute here, we have that power is equal to mg, or 2mg, let's write here 2mg divided by the time, which is 1. 2 divided by 1 is 2. So the answer is going to be for power 2 mg. If you go to the questions here, the answer will be B. Very good question, guys. Thank you for watching. I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.